In this video, we will use the inverse trig functions in scenarios where the vertex of our angle is not at the origin. So let's look at the following context. We have an angle with a measure of theta radians, and the vertex of the angle is at 2, 1, and a circle with a radius of 2 units is centered at the vertex of the angle. The terminal point of this angle is 3.24, 2.57. We want to know the radian measure of this angle. So since our terminal ray points to the top half of the circle, we'll use the inverse cosine function. Now the inverse cosine function takes a number of radii to the right of the center of the circle as its input. So if we look at this terminal point, it's some distance to the right of the center of the circle. Since the terminal point is at x equals 3.24, and the center of the circle is at x equals 2, the terminal point is 3.24 minus 2, which equals 1.24, units to the right of the center of that circle. Since the radius of the circle is 2 units, that terminal point is 1.24 divided by 2 radii. So 1.24 divided by 2 radii, if I could spell that, radii, to the right of the center of the circle. So the cosine inverse function, so inverse cosine of 1.24 divided by 2 should give us the measure of this angle. So theta will be equal to cosine inverse of 1.24 divided by 2. If we plug that into our calculator, we should get a value of about 0.9. If we look back at our diagram, a measure of 0.9 seems pretty good. So theta is equal to about 0.9. Let's look at one more example. We have another angle whose vertex is at 2, 1, and a circle with a radius of 2 units centered at the vertex of the angle. This time our terminal point is at 3.6, negative 0.2. Now looking at this diagram, we're assuming that the measure of this angle is between 0 and 2 pi. Now since the terminal ray points to the right half of the circle, we will use the inverse sine function. So the inverse sine function is going to take a distance above the center of the circle in radii as its input. So that terminal point, its y value is negative 0.2, and the center of the circle has a y value of 1, so the terminal point is negative 0.2 minus 1, which equals negative 1.2, units above the center of the circle. Since the radius of the circle is 2, that terminal point is negative 1.2 divided by 2, which equals negative 0.6, radii above the center of the circle. So negative 0.6 is a number of radii above the center of that circle. So if we compute sine inverse sine of negative 0.6, that gives us a value of about negative 0.644. Negative 6.444 is not the value we're looking for. That would give us this angle measure right here. So negative 0.644 gives us this angle right here in red, and then we need to rotate one full rotation in the counterclockwise direction. So we start at negative 0.644, and then we'll just add an additional 2 pi radians to take us one full rotation around, and that will give us the same result as rotating by theta radians. So that will give us the same result as rotating by theta radians. So in this case, theta is equal to the negative 0.644 plus 2 pi, which gives us a value of about 5.64. Now looking at this diagram, 5.64 radians appears to be the angle we're looking for. So in this case, we can say theta is about 5.64.